Welcome to Clarity in a Messy World, the podcast that looks at the causes behind the most confounding issues of our time. I'm David Wayne Callahan. In every episode, I'll be speaking with experts who will share their knowledge and insights and help us to untangle a seemingly chaotic world. Clarity in a Messy World is a production of Bocconi University, Milan, in collaboration with the Bocconi Student Media Center. As Edgar Allan Poe proved in his tale The Purloined Letter, sometimes we can't see what's right in front of us. It seems to be the case with climate change, a phenomenon so huge that we are sometimes unable to envision it. To prove climate change is real and demands immediate action, perhaps we should focus on something else, a proper way to measure it. Joining us today is Professor Valentina Bosetti. Valentina is Professor of Climate Change Economics at Bocconi University. She's one of the lead authors of the Fifth Assessment Report of the IPCC, or Intergovernmental Panel on Climate Change, the UN body which was awarded the Nobel Peace Prize in 2007. And she will be one of the lead authors of the Sixth Assessment, to be published in 2022. She's the recipient of 2 ERC grants, the competitive funding assigned by the European Research Council, for research on climate change economics. Valentina is also the chair of Terna, the first grid operator for electricity transmission in Europe. Valentina, thank you so much for joining me today.
Thank you, and hi, David.
In America, as well as in other countries, it seems that the factual existence of climate change seems to come and go depending on the political party currently in power. If there is no question, why is there still a question?
Well, we do have a lot of people questioning whether the Earth is flat or not. So I think this is simply part of that movement. If you don't see it and if you don't trust science, there's many known facts that you will not trust. And then on top of that, there are a lot of people who might help you in finding reasons not to trust science. So it's both the fact that we don't see it, we cannot touch it, and the fact that many people that have a lot of audience keep pushing on the fact that this is not real.
Carbon emissions seem to be the preferred metric for governments and companies to measure their efforts against climate change. Is that all there is? And is temperature the only target variable?
So, first question, is carbon emissions all there is? Well, a long time ago now, in the late 60s, 2 researchers, Manabe and Weatherald, published an article that basically is the most influential climate modeling paper of all time. This article was the first credible prediction of what would happen if we were to change levels of CO2 in the atmosphere. So when we emit CO2, it goes in the atmosphere and stays there. And they ask themselves, what will happen if we double the level of CO2 emissions in the atmosphere? The result was what we call climate sensitivity, basically how much temperature reacts to a doubling of the atmospheric concentration of CO2. And if you're curious, that's about they said it is about 2.4 degrees Celsius. So if you double CO2 in the atmosphere, you're increasing the temperature by about 2.4 degrees Celsius in average. And what is incredible is that a lot of research has happened since then, and that's a very accurate estimate still today. So emissions are very, very important. And if you want to simplify it in your head, you can think that if you take all the emissions we do and you accumulate those emissions, basically that's correlated with temperature increase. And is temperature, the second question is temperature a good proxy of what will happen? And I would say yes, it is, because temperature is correlated to all of the bad effects of climate change. But if you were to, using some miracle or maybe some technologies that we can call climate engineering and decrease temperature alone, leaving the concentration as it is of CO2 in the atmosphere, you would still have bad effects, for example, on oceans, because concentration in the atmosphere is in communication with concentration of CO2 in the oceans, and that is causing what's called ocean acidification, and that's bad per se. So temperature is very important, but there's more, and that is correlated with the concentration of the CO2 in the atmosphere.
When talking about climate change, we often think about extreme weather as the most immediate danger, but we tend to ignore the many social consequences, such as its impact on our food supply, water, health, and transportation, to name only a few. Should we shift our focus?
We should not shift our focus, because one of the most important implications of climate change, one of the most evident is the increase in extreme events. And extreme events range from anything from droughts to, what you might imagine when you think about climate change the most, which is extreme heat waves. But there's much more than these extreme weather events. Indeed, there are a plethora of studies now that have looked into the implication of gradual change in temperature on a lot of indicators of humans' well-being. And all of these studies point to a causal relationship between temperature increase and many, many different indicators, ranging from mortality of humans to decrease in crop yields to decrease in productivity in labor, up to extreme events like crimes and other events. So all this empirical evidence is showing us that there is a potential for many correlated bad events associated with increase in temperature. But there is more than this, because what I've been talking about is looking at the gradual implications of climate change. But we know there might be non-gradual events. What do I mean with that? I mean that maybe we will tip points, we will trigger events with no return, changing completely some of the natural systems. Think, for example, to boreal forests or coral reefs. If that happens, then we might have events that are much more rapid, not just negative, but very, very fast changing. These are so-called nonlinear events and are also very important.
As we've seen in many Hollywood films, yes, harrowing.
Well, some of those movies are fun, but in some cases, there is a part of truth in what they're showing us. Obviously, they're always too rapid because it all happens in 2 hours.
Yes.
And it won't happen in 2 hours.
Valentina, achieving accuracy in weather forecasts has always been challenging. But what about climate forecasting or predicting the behavior of the interconnected natural and human systems? Is there a reasonably accurate way to perform such a task?
Well, climate modeling has shared roots with weather modeling. They were the same thing at the very beginning. Mm-hmm. And both were born basically from military needs. When you know how to predict the climate, you have an advantage vis-a-vis your adversary. Weather and climate research was always connected and funded through military money. The first models were really done pen and paper. So all these efforts were at the very beginning happening in the US. But suddenly, because a lot of countries want to have, this that looks like military advantage, we're also developing similar models. What I like about the story of climate modeling is that it's the story of the first truly international research network. And these people, in a period where there was Cold War, where Russian and Americans were not talking, etc., these people were researchers that were really trying to share findings, share models, and this generated what's called community science. The first truly international conference of scientists was basically to look into the issue of climate and weather forecasts. All these early efforts led to the fact that in the late 60s, the community of climate scientists knew the existence of climate change, and they knew the basics of what we know today were already known back then. So what happened then is that they informed policymakers, and this happened mostly in the US through a set of National Academy of Science reports. What happened then was that basically when policymakers started to be aware of the problem, they asked the key question, and the key question was, should we care? Should we do something about this? Should we spend money to change what's happening?
Interesting. And how important is cooperation among scientists in different fields in developing accurate projections?
That's very important, because when you start to ask the question, should we put money on this? You are asking a different question than, is it happening? So you don't need climatologists alone anymore. You need to have a lot of social scientists at the table. You need to have economists. You need to have people that study the impacts of the changes in climate. And this is when the game gets really tough, because you have to sit at the same table people with extremely different background and disciplinary backgrounds. Mm-hmm. So that's when you need to have, typically in that time, men who believe in their science and not much in other sciences to talk to each other. I think at the beginning it must have been really exhausting, but in time, scientists working at this project, the project of understanding the implication of climate change for humanity, have developed models that are called integrated assessment models. And these groups are truly interdisciplinary, and they truly make an effort to talk multiple languages.
Valentina, you're a climate change economist. What is the role of economics in this endeavor? And for the record, in 2018, a climate change economist, William Nordhaus, was awarded the Nobel Prize in Economics.
So I'd say that economics has a lot to say to the problem of climate change. And for many, many years, this was not considered mainstream, not easy to publish in mainstream journals. And so a lot of young, talented economists didn't really think about this problem. I think things are changing now with this award, because that gave a signal to the whole community of economists. But economists has to say about evaluating these impacts. We need to know how much they will cost, because we have to get a sense on whether it's worthwhile putting the money to stop climate change. Mm-hmm. And if you show how much you could lose from doing nothing, from simply not acting to solve the problem, then you can more easily convince people, policymakers, that something should be done. So this is the foremost important task of economists, but also evaluating how much it costs to do something is important. Evaluating which policy instruments should be used. And recently, more and more, there's a lot of talking about monetary policies and how they might help in solving the climate problem. Think only about the fact that when we talk about recovery fund, a lot of people are talking about the recovery fund to be used to mitigate emissions. So obviously, economists have to think about this problem more and more and have to understand it and think of solutions.
In critical issues such as climate change and, in our recent experience, a pandemic, cost-benefit considerations might seem somehow out of place. In your opinion, do such considerations make sense?
I do teach cost-benefit analysis to my students. Mm-hmm. And then I explain to them, we should not use it for climate change. And why is that? Because I think cost-benefit analysis is an important way or frame to look at a problem, but you need to be sure that you're able to understand and monetize all costs and benefits. And in the case of climate change, some of the damages are very hard. We don't even know what these damages will be, and imagine, monetize them, describe them in monetary terms. It's a super hard problem. We only have started to understand, many of these damages. But then it's not just that. We have to be able to aggregate damages across people on this planet and across people who are not born yet. So even if you were to find a normative way of doing that everybody on the planet accepted, you still don't have all the damages in line and monetized. So I think it's not a good idea to apply cost-benefit analysis to a case like this. And what then? So I think it makes sense to do something we call cost-effectiveness analysis, which is simply the following. Because we don't know all these damages, we resort to science and a debate between science and policy. And this debate has given us a target. This target is not the result of a cost-benefit analysis. This target, which is the famous 2 degrees above pre-industrial temperature, as the maximum increase in temperature that we will allow, this target is based on what we know might happen if we cross the threshold. So we take this threshold and then we use economics to design pathways, to design strategies that will give us this target at the minimum cost. This made much more sense in the context of climate change, because to define the optimal temperature, you could, if you were God, or you could, if you had studied, maybe one day we will be able to do that. But at the moment, we don't have enough information. And so I think we have to do a step back and ask scientists, where do you think, is where we need to stop, not to screw it up completely? And there we stop. And then economists can tell us, what are the strategies to get there? I think that's an approach that makes sense in the case of climate change.
You mentioned optimal temperature, and I've been hearing a lot about something called optimal temperature increase. Now, going back to our William Nordhaus, in his 2018 Nobel Prize lecture, he describes a 4 degrees Celsius increase in global average temperature as optimal. That is, the point in which the costs and benefits of mitigating climate change are balanced. Now, that idea has proven controversial, so just what is optimal temperature increase, considering that most people probably assume that the optimal increase would simply be 0?
0 we cannot afford. 0 would really require efforts that, are not imaginable at the moment. Mm-hmm. We will probably, I hope, if we don't fail our future, we will get the 2 degrees maximum increase. What Bill was showing in that talk was how different it is. The optimal, meaning if I do cost-benefit analysis, vis-a-vis the 2 degrees. And he showed a temperature increase that is larger, exactly for the reason that I told you before, because we cannot fully monetize all the damages. And so given that we have damage function or monetization of damages that is not big enough, or we discount it a lot, then basically the model tells us to let the temperature increase more than the 2 degrees. But that's simply, that's an input of the model. That's simply because we are not good enough in capturing all the damages. And he admits that. That's why he himself now works mostly with this idea of taking the target from science and then finding the optimal way of achieving that target, rather than attempting to define a target or a maximum increase in temperature based on, the very poor and scant information we have on the cost of climate change.
Valentina, humans have experienced changes in climate before, in the form of ice ages, floods, warming periods, and even extinction events. Surely the fact that we're still kicking around in the 21st century proves that we're resilient and able to adjust to radical changes. Is there something different this time around?
Certainly there's speed. Speed is different than recorded in, ice cores and what we see about changing in temperature. Mm-hmm. Although there has been fast changes in the very, far past in some cases. The other big difference is that it's caused by us, which I think, it's not natural. It's not just happening and we have to run and hide ourselves in a hole. We are causing it, which I think makes a big difference. But the third element for me is that we should not be scared of extinction. It's not extinction the problem. The problem is we have almost 8 billion people and want these people to thrive on the planet, not to, suffer because crop yields go down and because, droughts bring a lot of people out of their country and pushes them to migrate. We want to live in the best possible conditions. We don't want to push ourselves in a situation of extreme, which doesn't mean maybe extinction, when extinction might even be better than living that kind of life. So I don't think we should think about extinction. I think we should think of, we are now at a level of maturity as human beings that we should thriving for the best possible condition rather than the worst possible conditions to live in.
Of course, thriving instead of surviving. Why is it so hard for humans to understand this specific kind of change? And to revisit the first question, are policymakers so different from common people?
The problem is that it's a gradual event. Our brains are not apt to concentrate on or care about. Mm-hmm. We know that weather changes, and so we are tuned with this variability, and it's very hard for us to get a sense of the fact that it's not just a simple, random different draw from the weather distribution. It's instead that the whole distribution is shifting. So it's very hard for us, for our brain, to get a sense of that. And policymakers are simply the same, but in some sense, they have a big disadvantage, which is they are measured on 5 years horizon, 4 years in some cases or countries. And when you're measured, or when your value is measured against such short time horizons, then basically this is not the right problem to pick, because even if we do something immediately today, we are still going to see some climate change happening because of the emissions we've done in the past. There is a lot of inertia in the system. Mm-hmm. We are not going to see the benefits of our policies tomorrow, not even in 5 or 10 years. This is a longer time horizon problem, and why should a policymaker invest in that when
it's not politically expedient?
No. So simply it doesn't make any sense unless you are, forced by some to think about the future by some other mechanisms that are not there at the moment.
Greta Thunberg has been showered with attention, awards, and honors, but do you believe her activism was just a flash in the pan, or will it have a lasting effect on global awareness and action?
We have studied this phenomenon with two colleagues, Silvia Piant and Matt Cisco, recently, and we looked at the implication of her movement, the whole Fridays for the Future movement, on attention to climate change. And what we saw is a very strong effect that only lasts few days. So there is an effect that you could think of, using this momentum to do something, but is very short-lived. There are longer waves, though. One of these longer waves is embodied in the fact that a lot of students want to study climate change and climate change economics. That obviously means that you're going to have people doing any kind of work in the future who are knowledgeable of the problem and of the potential solution. So this is a much longer wave, not just the heart that the young generation has in the problem, but the fact that they're studying, they will be prepared to do something about that in the future. The big question is whether COVID is the seawall against which this longer wave is going to break. And I have no answer to that. For sure, something will change when this younger generation will be in position of powers.
Well, Valentina, thank you so much for your candor and your insights.
The pleasure was mine, and I wish you all a great day.
I'm David Wayne Callahan, and this has been Clarity in a Messy World, a podcast from Bocconi University, Milan. Thanks for listening. You can find references from this episode in the podcast notes. To be notified when new episodes come up, subscribe to Clarity on Apple Podcasts, Google Podcasts, Spotify, or Spreaker.